Welcome to G Fun Facts Online. Today, we are dissecting the most significant inflection point in the software development industry since the advent of the internet itself. We have officially moved past the hype cycle of asking, will AI replace us, and have landed firmly in the era of AI-augmented software delivery. This is no longer about simple automation or smarter autocomplete. It is about a fundamental restructuring of the software development lifecycle, or SDLC, where artificial intelligence acts as a force multiplier, a guardian of quality, and, increasingly, an autonomous agent of change. By 2026, the question for engineering leaders is no longer if they should adopt AI, but how to weave it into the very fabric of their delivery pipelines without unraveling the security and culture that hold their teams together. In this episode, we are going to explore the landscape of AI-augmented delivery, from the rise of context engineering to the deployment of autonomous agents, offering a roadmap for how this evolution is actually happening on the ground. To understand where we are going, we first have to distinguish between the automation of the past and the augmentation of the present. Traditional DevOps was built on deterministic automation. It was rigid, rule-based, and fragile. The logic was simple. If event A happens, trigger script B. But consider the fragility of that model. If a UI button moved 5 pixels to the right, a Selenium script would fail. If a server logged through an unknown error code, the pipeline halted until a human intervened. That is the old world. The new world of AI-augmented software delivery is probabilistic and adaptive. It does not just follow rules, it understands intent. In the old world, a script runs a test suite, and if it fails, it sends an email. In the new world, an AI agent runs the test suite. If it fails, it analyzes the stack trace, correlates it with recent code commits, identifies the likely culprit, generates a fix, runs the test again to verify the fix, and only then alerts the human developer with a solution ready to merge. This shift changes the primary constraint of software delivery from human typing speed to human verification speed. We are transitioning from a world where code is scarce and expensive to one where code is abundant and cheap, but trust is at a premium. This augmentation rests on 3 pillars. First, it is predictive, not just reactive. Traditional monitoring tells you the server is down. AI-augmented delivery tells you the server will go down in 20 minutes because of a memory leak introduced in the last deployment, and it auto-scales the infrastructure to compensate while rolling back the bad commit. Second, it is context-aware. Generic AI tools, like a basic chat GPT interface, are useful but limited. The real power lies in tools that understand your specific codebase, your architectural patterns, your variable naming conventions, and your business logic. And third, we are seeing the rise of agentic workflows. We are moving from chatting with your code to agents acting on your code. These are autonomous loops where AI plans, executes, and critiques its own work before presenting it to you. Now, let us walk through this new AI-augmented SDLC, phase by phase, because the linear waterfall model is dead, and even agile loops are being reshaped. It starts with phase 1, planning and requirements, or the shift left of intelligence. The biggest source of waste in software is not buggy code, it is building the wrong thing. In 2026, product managers rarely write Jira tickets in isolation. They draft a rough intent, and an AI analyst reviews it against the existing codebase and historical documentation. The AI might flag that a requirement contradicts a security policy defined in Q3 of 2024, or that a requested feature looks similar to a user roles module built last year, suggesting an extension rather than a rebuild. We are also seeing dynamic PRD generation. Instead of static product requirement documents, teams act out scenarios with AI personas. A developer can simulate a user interaction with a virtual customer agent to uncover edge cases that would normally only be found in production. Moving to phase 2, design and architecture. We now have text to architecture. Architects use generative design tools to visualize system interactions. A prompt asking for a scalable event-driven architecture for a payment gateway handling 10,000 transactions per second yields a detailed diagram complete with recommended cloud services, potential bottlenecks, and cost estimates. This also applies to legacy modernization. One of the most potent uses is explaining the unexplainable. AI tools ingest millions of lines of COBOL or legacy Java, map the dependencies, and suggest a microservices decomposition plan, effectively de-risking modernization projects that have been stalled for a decade. Phase 3 is coding. This is the most visible change, often called the era of the 10x developer. Tools like GitHub Copilot, Cursor, and Tab9 have become non-negotiable, but the skill set has changed. The skill of the modern developer is not memorizing syntax, but context engineering. This involves curating the context window of the AI, feeding it the right interface definitions, database schemas, and design patterns so it generates code that actually compiles and runs. Boilerplate is dead. Writing CRUD APIs, unit test skeletons, and data mapping layers is now instant. Developers spend their energy on the business core, the unique logic that differentiates the product. However, this creates the junior paradox. A senior developer with AI is a superhero. A junior developer with AI is a risk. Without the grunt work to learn from, juniors may struggle to build the mental models needed to debug complex systems. This leads to experience starvation, a critical issue we will touch on later. Phase 4 is testing, characterized by self-healing and visual AI. Tools like AppleTools have revolutionized UI testing. Instead of checking if a specific CSS class exists, visual AI looks at the page like a human does. It ignores minor rendering differences, like a 1-pixel shift due to a browser version, but catches meaningful breaks, like a buy button overlapping text. We also have self-healing scripts. In the past, if a developer changed a button ID, the test failed. AI-Augmented test runners detect this change, realizing that while the ID changed, the button is in the same location with the same behavior, and update the test script automatically. Furthermore, you can paste a user story, and the AI generates the gherkin syntax, the step definitions, and the negative test cases you forgot to think about. Finally, Phase 5 is deployment and ops, or AI ops. Platforms like Dynatrace and Datadog now ingest petabytes of operational data. They do not just alert on high CPU, they correlate it with business metrics. They might report that checkout latency is up 200 milliseconds, which correlates with a 5% drop in conversion, identifying the root cause as a database locking issue introduced in a specific release, and recommending a revert or a specific index application. Security has also evolved into a security fabric. Tools like SNCC using deep code AI scan code not just for known vulnerabilities, but for logic flows that look vulnerable. They can auto-fix vulnerabilities, creating a pull request that patches a security hole before the security team even sees the alert. Let's look at some real-world case studies to see who is actually doing this. First, take GitLab and NatWest. The UK banking giant NatWest needed to modernize software delivery while adhering to strict financial regulations. By adopting an AI suite, they integrated AI directly into their workflows. The bank did not just write code faster. They used AI for automated compliance checks and test generation. This deepened trust in their engineering rigor rather than diluting it, unlocking economic value by saving developers hundreds of hours on toil. Then there is WalkMe and AppleTools. WalkMe supports thousands of website overlays. Testing their product across every browser and device combination manually was impossible. By implementing visual AI, the team saved 2 months of man-hours per release cycle. They increased test coverage from 3 browsers to 10 without adding headcount, catching visual regressions that no standard automation could ever find. And consider SNCC. As developers used AI to write code faster, they were introducing vulnerabilities faster. Traditional security scans took too long. SNCC's Deep Code AI, which combines symbolic AI with generative AI, provided real-time fixes. Companies using this AI security fabric reported a 75% faster remediation time. Instead of a security ticket sitting in a backlog, the AI suggested a fix that the developer could accept in seconds. Looking at the tooling landscape of 2026, the market has consolidated into a few key categories. The copilots include GitHub Copilot, which now has workspace awareness to refactor across multiple files, Cursor, an AI-native code editor allowing for composer mode where the editor writes files and runs terminal commands, and Tabnine, the privacy-focused choice for enterprises running models locally. The guardians include AppleTools for visual AI and SNCC for code quality and security, acting as AI gatekeepers that block unverified AI-generated PRs. The operators include Dynatrace Davis, a causal AI engine offering precise root cause analysis, and PagerDuty process automation, which uses AI to group thousands of alerts into single incidents. But the most dangerous myth is that AI makes software engineering easy. It makes syntax easy, but it makes system design harder. This brings us to the human element and the skills for the augmented age. Prompt engineering is dead. It has been replaced by context engineering. This is the architectural skill of designing the information flow that feeds the AI. A context engineer decides what documents the AI needs to see, how to index the codebase so the retrieval augmented generation system retrieves the right snippet, and how to sanitize data so the AI does not leak personally identifiable information. We are also facing a verification bottleneck. In 2026, a developer spends 20% of their time writing code and 80% acting as a lead reviewer for the AI. There is a trust deficit. While much code is AI-assisted, developers often do not fully trust it. Reviewing code is harder than writing it, especially when the code looks plausible but contains subtle logic errors. This connects to the junior developer crisis. Organizations are facing a senior-only problem. Because AI can do the work of a junior dev, companies are hiring fewer juniors. But if you do not hire juniors, you never get seniors. Progressive companies are solving this by turning juniors into AI operators. Their job is to orchestrate the AI agents, verify the output, and focus intensely on learning architecture and business logic earlier in their careers. Governance is crucial here. Shadow AI, where developers paste proprietary code into public chatbots, is a massive security risk. You cannot ban AI, so you must govern it. The industry standard for 2026 is the Traffic Light Protocol. Green is for approved tools like Enterprise Copilot or self-hosted LLMs, which are safe for proprietary code. Yellow is caution, for public chatbots where no code or API keys are allowed, only general logic questions. Red is banned, covering unknown or unvetted plugins that might scrape data. The key policy rule is the human-in-the-loop mandate. A human must review and sign off on every line of AI-generated code. The AI wrote, it is not a valid defense for a production outage. As we look toward the end of the decade, 3 trends will dominate. First, agentic workflows will move us from human-in-the-loop to human-on-the-loop. Agents will have permission to create a branch, write the code, write the test, deploy to staging, and then simply ping the human to approve for production. Second, self-writing software. Applications will self-optimize. An e-commerce site might detect a slow SQL query, rewrite it, test the optimization, and hot swap the code without a deployment window. Third, the rise of the software naturalist. Developers will become more like biologists, observing complex, evolving AI ecosystems, pruning them and guiding them, rather than acting as the bricklayers of the past. In conclusion, AI-augmented software delivery is not a tool you buy, it is a way of working. It offers the promise of releasing software at the speed of thought, but it demands a higher caliber of engineering discipline to manage the chaos. The teams that thrive in 2026 will not be the ones who code the fastest, but the ones who curate context the best, govern their agents the wisest, and never lose sight of the fact that software is ultimately built for humans, by humans, even if the heavy lifting is done by machines.